Hello everyone. So today we're going to talk about second mission of graphing functions, and the main focus will be on plotting some order pairs, talking about what the function means for a table or for given order pairs. Do we have a function or not? How to check for this. So go ahead and write down the name of this lesson: Graph Picture Activity Plot Points on Coordinate Plan, and we will be able to tell whether the pairing is a function. After we're done with the lesson, we will do some practice assignments and we'll discuss if the picture project will be the opportunity or 4.1 worksheet. We may have a couple choices here. That will be in-class discussion. And once you have the name written down, go ahead and draw a picture of this. So when we talk about functions, again, we have the coordinate pair that has x and y coordinates. X coordinate, it's called domain. We already talked about this, but also we call it input. So there's just another term to remember, unfortunately, but this is math and we have a lot of things. So domain and input is the same exact thing that represents variable x on the table or on the coordinate order pair. And output is the y coordinate that also is called range. So you are familiar with both of those, domain and range already. X is domain, y is range, but also x is called input, y is called output. So why some people call this input, y output? Because whatever we give for x, and remember when we draw the tables we said we can always give some numbers for x, so we can give any numbers for input x, but the output will be different and we don't know what the output is because we have to calculate it in order to get y values. So in cases when we have just numbers 0, 5 and 10, and let's say 0 input gives us y equals 2, or 5 output gives us y equals 3, or 10 for x value and y equals 5, this shows us that for every input, individual input different than other numbers, we have a corresponding output. When it's not function, so a given equation would not be function if we have the same numbers of repeating numbers for x. Let's say we have 2 zeros here, and imagine this is a table. We cannot have 2 zeros. This is not possible. So this will give us no function because the numbers for x should not repeat. That means if you look at down those two tables, now look at the first one. We have input domain x with values 3, 6, 9, 12 and output with 1, 2, 2, 1. Now x values are all different numbers. We are good here. Y values repeats. That's okay. That is perfectly fine. The goal is x values to not repeat. So yes, this is a function and we can plot a couple points. So let's plot this point. We have x positive 3. If you draw x and y coordinates on your piece of paper, make sure you put scale of 2. So I put 2, 4, 6, 8 instead of 1, 2, 3, 4, 5, 6, just because this is a very small coordinate plan and I don't have this much space. So my scale, again, instead of counting those blocks 1, 2, 3, 4, 5, I decide to go by 2. So 2, 4, 6, 8, 2, 4, 6, 8, negative 2, negative 4, negative 6, negative 8, and same thing for y coordinate, negative 2, negative 4, negative 6. So once you have your plan, coordinate plan written down with the labeled scale, we're going to go ahead and plot this point. So the first point, x is 3, y is 1. When x is 3, 3 means between 2 and 4, somewhere here. And y is 1, so this is 0, this is 2, then 1 will be in the middle. So this point is the first one from this table. And we will do just one more. So you guys could see what we're doing. We don't need to go through the whole thing. So the second point, 6 for x. So here's positive 6 for x, and then we have positive 2 for y, which is right here. So that will be the second point. And if I keep going, I will continue plotting my points. Now, look at the second table. We have input x with numbers 2, 2, 4, 7, and output y with 0, 1, 2, and 3. What do you notice here? Well, I hope everybody see that x input has two numbers too. And we just said at the beginning that the input x values should not repeat. If they repeat, what happens is the answer is no function here. No function. And we don't graph it, because if there is no function, we cannot graph it. It's going to be just some lines going up and down and some different directions, and that would not make sense. Okay? So when you have given table, first thing, make sure x values are all different. If x values repeat, we have no function, we don't graph it. Awesome. So pause the video to finish what I just said. Replay if you need to. Otherwise, if you're ready, you can just move on with me. Next example that I want to show you is very similar example to the first mission that we discussed, and we have given a function that says y equals 2x plus 3 with domain 3, 5, 7, 8. So make a table for the function, identify the range of the function. So imagine the table wasn't given, okay? We don't see this table. If we don't see the table, then what you need to do is you have to make your own table. So sometimes, if we don't have given table, you gotta think about, alright, so the domain means this is my x values, okay? So what I need to do, I need some x values, and I need to calculate what the y values, what is the range. In order to calculate this, I need this function 2x plus 3 in the middle, and that will help me to get everything what I need. So once you set up your table, now let's go ahead and fill out the missing parts. It's given for us that the domain x has those numbers. So we have 3, we have 5, we have 7, and 8. Those are given for us, so we don't need to come up with random numbers. To get y values, we will substitute x in the function, so will be 2 times, instead of x we put number 3 here, and then plus 3. So 2 times 3 is 6, plus 3 will give us 9, y will be 9. Then the second one, we are using exactly the same function, 2 times, instead of x, put number 5, plus 3. 2 times 5 is 10, plus 3 we get 13. Next one will be 2 times, now instead of x we put 7, plus 3. 2 times 7, 14, plus 3 will be 17. And the last one, 2 times 8, and again plus 3. 2 times 8 is 16, plus 3, 19. So to identify the range of the function, it means this. We just got what the range is equal to, and we're done with the example. Okay, so hopefully this start making much more sense to you, and you start getting to understand the steps of figure out or finding out what the function is and how do we get the range values. Example. Alright, so the last example is another real life example, and let's see how do we use functions in order to do some calculations and talking about linear functions actually in the real life situations without even realizing that this is happening. So you're buying a concert tickets that cost $15 each. You can buy up to 6 tickets. What is the amount in dollars you spend as a function of the number of tickets you buy? Identify independent and dependent variables, then identify the domain and range of the function. Alright, so I want you to write step 1 as the first thing. Step 1. So if I need to write this as a function, I would say y is equal, y is the amount we spent. So how much money we're gonna spend, it depends on $15 per ticket. Okay, so one ticket is $15, and this will give us the total amount we want to spend, right? Okay, so using this concept, we know that y, okay, so we gotta make a table. X values is the number of tickets, and then we have y, which will be total cost, dollar amount. So that's the first thing, because again, if you think about $15 for one ticket, it will be $15 total, but if we have $15 times 10 tickets, this will be $150. So the independent variable that does not change, x, is the number of tickets, and we have up to 6. So I'll put 1, 2, 3, 4, 5, 6, total 6 tickets. The ticket itself does not change. You can't have half ticket or 3/4 ticket or 1 3/4, right? It's 1 ticket or 2 tickets or 3 tickets. Now, how much we're gonna pay? Well, that will depend on the ticket's number. So if I have 1 ticket, I pay $15. If I have 2 tickets, pay $30, 3 tickets, $45, 4 tickets, $60, 5 tickets, $75, and 6 tickets, $90. So this is my table. This is how I set up the problem. So after I'm done with step 1, step 2 will be to graph it. Step 2, and also final step, is to graph it. So I'm gonna make my y coordinate and x coordinate, and we already said that y will be number of tickets and x will be the dollar amount, total cost. So number of tickets, I can count 1, 2, 3, 4, 5, and 6. The cost will be because we have $90 here, so I'm gonna put scale of $10. So $10, $20, 30, 40, 50, 60, 70, 80, and $90. This range will help me to plot the points on the coordinate plan. So first point, x is 1. Oh, did I mess up? Yeah, I switched those. Okay, so x is 1. I will erase that and just change it because I messed up. X is actually tickets. So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If we talk about 10 tickets, sorry about that. And this will be the dollar amount here. Okay, so this will be the price, and I will go 10, 20, 30, 40, 50, 60, and we gotta keep going, 70, 80, and 90. So maybe we can do just a few points. Alright, so sorry about that again. Let's begin. X1 ticket, here's X1 ticket, cost $15. So that's my first point on the graph. Then second point will be 2 tickets, cost $30, so right here. Then 3 tickets cost $45, which is right here in the middle. Then 4 tickets cost $60 right here. Then 5 tickets cost $75, so again this will be right here. And final thing, 6 tickets will be $90, which will be right up here. Okay, so look at this. We have a perfect linear progression. This is a great example of linear function that shows us the relationship is based on how many tickets we're buying, this much we are going to to pay for it. So if you buy 1 or 2 tickets, you pay less price, but if as a progression, if you go and buy more tickets, then the cost goes up and increases as well. Well, thank you very much for watching the video and being patient with me on this last example. We will have more discussions in the classroom, so be prepared with your questions. Post them so I would know as well what do I need to cover and discuss with you. Have a great day, everybody. Thanks.